In this video, I will port an existing HTML5 application to the BlackBerry 10 WebWorks platform. The video includes basic setup, configuring the viewport, as well as any UI changes required. The final result will be an application that looks good and works well on a BlackBerry 10 device. For information on how to get signing keys, set up the SDK and tools, package and deploy, please refer to the other videos in the series. Also, I strongly recommend watching the 101 series for core setup information. I will be porting the famous To-Do example HTML5 application. To-Do is a simple open source task manager implemented using many frameworks and available on GitHub at the following URL. To keep things simple, we will focus on the vanilla JavaScript example. Here's what the app looks like when running in a desktop browser. As you see, we're able to add and remove to-do items, which get stored using HTML5 local storage. Let's begin with basic setup. Every WebWorks application requires a config.xml file. This file describes the application name, description, author's details, and other information. Here's an example where I've set the minimum properties that will allow me to package and deploy this sample. In order to use BlackBerry WebWorks APIs in the application, we need to reference WebWorks.js within index.html. The WebWorks.js file is bundled with the application automatically, so the source should always point at local://chrome/webworks.js. Now that we have the most basic building blocks in place for a BlackBerry 10 WebWorks application, let's package and deploy it to see what it looks like on the device. At a first glance, it appears to look and work well, but if we try to pinch the screen, the application will allow us to zoom in and scroll around. This is not a good user experience for a BlackBerry 10 application, which brings us to the next section, setting up the viewport. To prevent zooming, we need to lock the viewport to a maximum scale of 1. This is done using a meta viewport tag as shown here. Let's take this a step further and also set the initial scale to a value that depends on the device pixel density. In order to comply with the UI guidelines, we need to ensure that the viewport size matches the physical dimensions of the device screen. In order to do this, we include a small calculation when inserting the meta viewport tag. This is explained in detail at the following URL. As you can see, we're no longer able to zoom in by pinching or double tapping on the screen. In order to provide a user experience consistent with other BlackBerry 10 applications, we need to make a few UI changes. First, let's take a look at fonts. The BlackBerry 10 UI Guidelines typography section describes how to set up fonts for designing BlackBerry 10 applications. The default font on BlackBerry 10 is Slate Pro, and if you don't specify a font or set the font family property to auto inside your CSS, it will automatically use this font. The typography page also provides the font sizes to use in order to maintain a consistent experience with other BlackBerry 10 applications. Let's take a look at the result after adjusting font size. Not bad. The text is easier to read and looks more fitting on the current screen size and resolution. The buttons, however, are too small. This brings us to the next section of UI changes. Touch targets. Touch targets are areas that expect user input via touch. The default touch target for a button, for example, is usually as big as the button itself. According to the UI guidelines, touch targets need to be at least 101 by 101 pixels. This is done to ensure the user does not miss and have to tap the button over and over again. Touch targets that are smaller need more precise touches, which leads to a bad experience, and in return, the user is less likely to use the application again. Here's what our application looks like with bigger buttons. Although it is easier to use now, you will notice that the buttons are still not 101 by 101 pixels. This is because, depending on the design of your application, 101 pixels may be too wide or too tall. The UI guidelines refer to the touch target dimensions, not the visible dimensions of elements. So we can have an invisible touch target under the element that's 101 by 101 pixels, while the element itself is smaller. This can be done using a neat CSS3 trick. Using the CSS3 before pseudo class, we can increase the touch target for an element without increasing its dimensions. By defining this pseudo class, we place an empty container under the element with its dimensions expanding beyond the element area by number of pixels in each direction. This trick does require you to explicitly set the position property on the element, which is why I've set the toggle element's position to relative. As you see, the blue area represents the actual touch area, which is at least 101 by 101 pixels. Lastly, remove unnecessary margins, empty areas, and further adjust the style to make the best use of the screen estate. Here's the final result.